Hi, and welcome to this year's Earth Day celebration. It's titled EPA and NASA Converses with Students. My name is Sala, and I'm very honored to have this opportunity to introduce EPA Region 7's very own Regional Administrator Meg McCollister, as she provides her opening remarks. Meg, the floor is yours.
Thank you so much. Good afternoon, everyone. Thank you so much for tuning in today. I'm thrilled to join forces with NASA to present this Earth Day celebration webinar. I always enjoy getting to work with other federal agencies because it really does take cumulative support throughout government to tackle the most pressing issues facing our country and, of course, to best serve the public. I recently attended a leaders retreat in Washington, D.C., and one of the highlights for me was listening to Bob Cabana talk about leadership. As many of you probably know, Bob is the former director of the Kennedy Space Center. He's certainly had an incredible federal career spanning more than 4 decades, and he's certainly learned a thing or two about leading organizations. And he talked about how leaders should inspire their team to understand where they fit into the overall purpose of the organization. I considered his recommendations as I made plans for our own organizational goals for 2024. And another thing that Bob said was that EPA has the coolest mission. Of course, I agree with him. Our mission is very cool. And it's also very relevant and urgent. And that's why we take what we do so seriously. We're passionate about creating a healthier and cleaner place to live, to work, and to play for everyone. And I'm excited to have so many talented and promising students join us today to learn more about what we do. At Region 7, we look for opportunities to share our work with young people because, as President JFK once said, children are the world's most valuable resource and its best hope for the future. I hope these webinars might influence some of you to consider a future in federal service, whether at EPA or at NASA or another agency, so that you can continue the work that we've started. Now, EPA is not the only federal agency that has a cool mission. I know that I can speak for all of us at EPA Region 7 by saying NASA has a pretty cool mission too. And we're always impressed by the research and work that is produced by NASA, and we welcome opportunities to learn from the team. Last year, we hosted a panel with NASA doctors Kate Calvin and Alex Ruane, who were a part of the writing team for the Intergovernmental Panel on Climate Change Synthesis Report, the IPCC report. As you know, the IPCC is the United Nations body for assessing the science related to climate change. It was a very informative panel that also addressed feasible and effective ways we can all secure a sustainable and resilient future for our world. So today, we are excited to welcome our panel of experts, both from Region 7 and NASA, to discuss how the use of visualization tools and applications assist in tracking trends in pollution and climate change. At EPA, we have a lot of experience in developing data visualization apps. We recently revamped our AirNow website and interactive map to allow users to view air quality over time for different pollutants. And during last year's fire season, we had the most visited federal website with millions of hits per day. And these tools and apps are really important and serve the public, especially during environmental emergencies. So I look forward to hearing more about these technologies. Before I hand it over, I want to thank Anita Day, the Strategic Partnerships Manager of Outreach and Engagement for the Science Mission Directorate at NASA. Thank you so much for partnering with us for these webinars. And to all of you tuning in, thank you again for joining us. And I hope you enjoy today's panel. So now I will turn the program over to Ellen Gray from the Office of Public Engagement at NASA's Earth Science Division.
Hi, and thank you so much for that welcome, Meg. So I'm with NASA's Earth Science Division, and it is sometimes the best kept secret at NASA that we study our own home planet. NASA has been in the business of looking down at our environment since 1960, and one of the most important things that we have is a treasure trove of information and data and observations from space, which give you a global view of our home planet that we see through the eyes of NASA. So if you want to go to the next slide, please. All right, so why does NASA study, and what is NASA's role in studying and understanding our home planet? Aren't we supposed to be going out into outer space? Well, the vantage point from space is gives us that global view, and it lets us see the entire planet from the Arctic to the Antarctic, all the way around. And an Earth observing satellite can do that in anywhere from 1 day to a week or two. And so you get this really incredible view of our planet. And NASA is a science and research agency. And what that means is that we invent the things that the tools and the technology to look at Earth from space. It means we build the satellites and we put them up there and we test them and we prove that certain technologies work or don't work, because that's part of the process too. We fund scientists. We have our own scientists who then look at the observations and the data that are coming in. And they're looking at not just like how they're affecting everyday lives, but the fundamental science and physics. And, you know, why does a cloud form this way? And why does a hurricane, come from the East Atlantic? And what does the Saharan dust layer have to do with that? So all these kinds of scientific questions that sometimes can feel far removed, you really need that understanding to understand how our planet is changing with the change in the climate that we're experiencing now. We also have invest and put in like all the data and the computing power to use that data. And the data that we collect is a public good. It is freely available to everybody in the public. It's freely available to scientists and researchers worldwide. And we're also continually improving the tools that we provide to use that data. We have a policy of open science, which means that we want everybody to be able to use the data, the algorithms, the models, all the tools of science to work with this data, because the more people we can get the data into the hands of, the more good we can do in the world. And one of our partners in that is the EPA. And this is that last little column right there, the Earth Action part. The data that we provide is available to the EPA to fulfill their mission of creating a healthier environment. And that is something that we're very proud of. We partner with a lot of federal agencies, we partner with state governments and local governments, and that's really what we want. We want to give the best information to these folks who are making decisions that affect everybody's lives. Next slide, please. So how do we do that? I mentioned that we invent the technology and then we build it and we put it in space. So what you're looking at here is a chart of NASA's Earth observing fleet of satellites. We have over 24 currently in orbit. If you look at the ones that are in blue on the inner of that spiral and go around to the green ones, those are the ones that are currently in orbit. The ones that are blue are in their extended life, and the ones that are in green are in their current mission life. The ones in orange are ones that are coming up soon. And actually that first orange one just last week launched into space, PACE, to study the biology of the oceans. And that one is now up in its calibration phase. We're checking it out to make sure everything works, kicking the tires, as it were, before it goes into science operation. And then those orange ones, those are the ones that are coming up in the next couple of years. And then those gold ones are the ones that are in what we call formulation. So they're still being designed and will be up. But one of the things I want to point out with this is you have so many of these things. And why do we have so many? Because they're each looking at different parts of the Earth system. Some of them are looking at the water, some of them are looking at the rain, some of them are looking at the atmosphere, some of them are looking what's in the atmosphere, not just clouds, but the tiny little particles like smoke particles or aerosol particles, or sea salt even, and understanding how those different parts of the Earth system interact with each other. Ice, oceans, land, air, those are the four fundamental things, and all the parts in between. And when you have the data from all these different satellites, you can create a better picture of what the Earth is doing, how it's changing in response to rising global temperatures with climate change, where you're seeing the effects of climate change in different parts of the world and what those trends are doing over time, because we've been measuring and we have a satellite record that goes back 50 to 60 years in many cases. So next slide, please. And one of the things we're going to be talking to you today about is data visualization. And as you can see in this image, we call it the beach ball. There's different types of data visualizations, data visualized here. You have what looks like a storm and the atmosphere, water moisture in the blue one, kind of towards the left side. And then on the right side, you have a different set of data over the same area that's in this rainbow colors. And what you have here is different data sets that then you can, with the visualization, you can link together and you can see multiple data sets together. And that's how we do a lot of our science, is understanding how one of these data sets interacts with another. And data visualization is one of those most powerful tools that we have to make that happen. Next slide, please. So when I mentioned our partnership with the EPA, we also partner with other agencies. So this is where that data goes. It's all good to understand how our planet works, but what we really want is to make sure it's useful, that it helps people and provides societal benefit. So, understanding fires, the top right image, the red dots are active fires, and some of the white, kind of the clear white, transparent white, is actually smoke from those fires. And we can see that from satellites, and that helps us provide information to the EPA, to other agencies about natural hazards, warning, and recovery. You see in the bottom left, sea level rise, and you have a city, a town that has been flooded. Sea level rise is a consequence of climate change, and it's all parts of the Earth system kind of converging on that affects communities. But it starts in the Arctic, and it starts with the warming oceans, and those two factors contribute to when you have the Arctic warming and you have Greenland and Antarctica melting the ice sheets, you have more water in the oceans, and then you have the warming of the oceans because of climate change, making the water expand so it rises up higher. And that is another thing that we look at and then transfer to communities and people who are making decisions about how to build towns, where to put seawalls, things that will actually affect coastal communities in their daily lives. On the bottom right, we also have applications, data that can be put towards applications in food security and water management, growing crops, understanding healthy plants. We can see whether plants need water from space. We can even see how much water they're putting back into the atmosphere from space. I mean, that's pretty cool. I mean, when I learned that for the first time, my mind was kind of blown a little bit. But those are some of the applications that the raw observations can support. And economic prosperity is kind of one of those that goes across all of these. As you can imagine, with food security and food crops, like that's an industry, right? That's supporting people's livelihoods. Fisheries are another one. I mentioned the new satellite we have up that's going to look at ocean biology, and that's the underpinning of healthy fisheries that, vast majority of the world's communities live near the ocean and depend on fishing or for food and or jobs. So there's lots of different ways that NASA data can be put into use and action. And one of the ways we like to convey this is through public events like this webinar, showing you how different parts of the Earth system work together. And one of the things we have is called the Earth Information Center, and that's what you're seeing photos of here. And this is an art and science installation. It's a way to try and make data tangible and visible. It's not just numbers on a screen, right? It's not the matrix, but it's these swirling oceans. It's this chandelier that actually shows when data is coming down from a satellite and when commands are going back up to the satellite. And we also have this immersive experience based on data visualization that really helps you understand and feel the wonder about our planet and how it's evolving. And with that, I'm going to turn it over to Mark, who is the real pro in data visualization, who will go into so much detail and hopefully show you how we see our own home planet through the eyes of NASA.
Thanks so much, Ellen. While we're on this side, I might just quickly, Kate has a question in the chat, and I think that's where do we access the data and algorithms? Well, it's actually a complicated, there are many places to access them, but I'd recommend you check out the website up there right now, earth.gov, at least a first start, and we're building that out, and hopefully to make that more of a sort of one-stop stop to get you a lot of at least NASA and our partner agencies data sets. Next slide, please. So I am the lead of NASA's Scientific Visualization Studio. That's a group that's been around for quite a while, building a huge library of data visualizations about all kinds of NASA science. So I just wanted to talk to you a little bit about what data visualization is. And here you see some different examples of our work. When you were listening to Ellen, she was describing all that data that NASA is collecting. I mean, you saw that huge fleet of satellites. And as these newer generations of satellites are coming, they have more and more instruments on them. They're pulling back larger and larger data sets. How do we make sense of that? How do we understand the information we're getting from them? And I'd like to argue that data visualization is one of the best ways to make sense of data, especially big, complex data. And so we'll just dig into that and give you some examples. Next slide. So what is data visualization? Well, it's really going from numbers to pictures. Here's an example. This is NASA's record of sea level rise. So Ellen was talking about sea level rise. It's caused by a variety of factors, but the warming of the oceans is caused by the climate change. The warming of our planet is causing the water to expand. It's causing ice to melt, and all of this is leading to global sea levels rising. NASA has a record, a satellite record of global sea level rise. It goes back about 30 years. And that's what you're seeing here. And this is like one row of data per month for those 30 years. All right. I'd argue that people are much better at understanding pictures than numbers. Even those of you who are good at math, even this is a relatively small data set, keeping 1,200 rows and 12 columns of numbers in your head is pretty hard. So how do we make sense of that? Let's go to the next slide. It turns out there are many, many different ways to do that. You have many different choices on how you translate those numbers into pictures, and that's where the creativity comes in. That's where art comes in. And I think part of why I love my job, and yeah, honestly, I think it's one of the best jobs you can have, is that you get to use both sides of these brains. You get to be a scientist, you get to work on the math, but you also get to work on the artistic side. So this is a relatively straightforward way of turning those numbers into an image. This is a line plot, one of the earliest data visualizations. And we can see some numbers there. Over those 30 years, the sea level has risen by about 100 millimeters, almost exactly, about 4 inches. If you look carefully, you notice some wiggles too. So I'm going to show you a different way of visualizing this data. If we go to the next slide, and we hit play. Now here, we're breaking that down by year. So you're seeing a line for each year, and you're seeing it rise as those lines go up. And each one of those little wiggles is showing you the variation over years. So there's some seasonal variation. This has to do with the fact that there's more water in one hemisphere than the other. So the warming of the ocean varies seasonally. Let's play that again, though. I'll just like dig into some of these different choices. So you also notice I'm not just plotting a line. The shape of that is kind of like a wave. So it's referencing the fact that it's water and rising water. The color is chosen to make it look like waves, right? So this is the art side. I'm trying to make you see the fact of what it is. I'm trying to reference the data, the meaning of the data in the colors I choose. And then you'll see a little twist at the end. It is a literal twist where we go from this plot that's showing us 1 year at a time to the more standard kind of line plot that you saw before. Right, so this is just one example of trying to be sort of creative with how you visualize a relatively simple data set. Let me give you another way to visualize the same data. If we go to the next slide, we'll see an image of the hyperwall at the Earth Information Center. You saw some slides of that before from Ellen. And this is our main data visualization display at this exhibit at NASA headquarters here in Washington, D.C. And it just so happens, and it's true, a lot of times the way you create a data visualization depends on the platform you're creating it for. So the kind of visualization I just showed actually works really well on mobile. I actually have a version in vertical format, so it looks better on Instagram. But when you're creating things for big immersive displays, you have to think a little bit differently. And in here, in fact, we have these circular displays. So we were thinking about how to show sea level rise in one of these data visualization dashboards. And we had this thought. Those circular displays kind of look like the porthole of a ship. And what if we imagined that we were looking out a ship's window and we were watching 30 years pass and we were watching the sea levels go up and up? So we created the following visualization. If you go to the next slide. So here we're looking out that window and we're watching the sea levels rise and we're making the water look like water. And if you are at this physical display, that scale graph, which is now meant to look like it's a periscope on a submarine, is at true scale. So 1 inch is 1 inch, 1 centimeter is 1 centimeter. And we see this, and we can watch that 30-year record of sea level rise. Interestingly, because we scaled this to fit this exactly display, it seemed unlike many of our visualizations, which we use all over the place, this one was specifically created for that one display. Yet despite that fact, this has actually become very, very popular on social media. Next slide, please. Here you see how it fits in, telling the story of how we're tracking the Earth's health and these different climate vital signs. So this dashboard lays out different key vital signs, be it sea level rise, be it the extent of Arctic sea ice, be it global temperature, be it the levels of different greenhouse gases, or the heat in the oceans. And showing them all together in this way helps tell a more complete story. That's the other aspect of this. And the other aspect is that by animating the data, by revealing one thing after another, we can not just show you the numbers, but we can tell you a story, which all of which leads to engagement. Um, let's go to the next slide. Another type of data visualization, which I just thought I would mention because we have a major event going up, is our maps, and that's putting geospatial data, putting data onto a map. Here's an example of a map for an event coming up on April 8th that I just want to mention because I don't want anyone to miss it. And this map can tell you exactly where you need to go to be in the path of the total eclipse. And also, if you're not in the path, like how large of an eclipse you're getting. But I would encourage everybody listening, if you're able to get in the path of the total eclipse, because this is literally a once in a lifetime experience and truly a profound experience to experience totality. So this is coming up. And if you want to figure out where to go, we have this beautiful printed map, but also you can get from us an interactive map as well that you can explore. Next slide, please. We can also put that data on a globe. So here's another example of a different data set. This is a data set showing the height of trees around the Earth. This is data collected by an instrument aboard the International Space Station. And you see lots of little lines because it's basically measuring the height of trees as it orbits the Earth. And slowly, over time, it passes enough to build up this more or less complete picture of tree height around the globe. And that information tells us not just how tall the trees are, but it can help us to a little bit even figure out how healthy they are, what different kinds of trees there are. Next slide, please. And this is a data visualization, another volumetric data visualization showing carbon dioxide. And you're looking at one of the, now we're looking at, before I looked at observational data, now you're looking at data from a computer model. And this is actually the highest resolution model of carbon dioxide that's ever been run. The pulsing you see is the breathing of the Earth. It's the Earth's forest taking in and putting out carbon dioxide during the day. And as you watch, you also see that buildup of carbon dioxide over the year. And it's this buildup. It's this buildup that's driving climate change, but it's also the interplay between the natural world and human emissions is very important to understand as we help and try to combat climate change. Let's go to the next slide. So, just to finish up, I just wanted to give you examples of some of the different kinds of data visualization we do. We'd love you to come check out our website where we have 9,000 different data visualizations that we've collected over the years. But just going back to that key point, the importance of data visualization, why we do it. What is data visualization? Well, I hope I've convinced you that, it's not just a way of understanding, but it's also artistic. It's something that's beautiful. It's something that can be creative, as well as being useful. And like I told you, I really think data visualization is fun. So I definitely encourage you all to pick up some of these skills. Being able to show something is often much more powerful than just being able to tell people about it. So thank you very much, and I'd like to pass it back to my EPA friends.
Thank you so much, Dr. Mark Subaro. So going to advance. Thank you, NASA, Ellen. That was a great presentation. So my name is Sala Nanyanzi Senkai. I do have a long East African name. I'm the Senior Quality Assurance Scientist at EPA, and I'm doing this, tag teaming this with Dr. Brian Chastain, who will speak here just shortly. Just wanted everyone to note down here at the bottom, we do have a disclaimer. It basically just states that visualization tools are very powerful at looking at data and information, as you've already seen. But again, these are basically visualizations of information. So we need to run statistics, sort of ground truth the items that we're about to talk about here on the EPA side. So here's a quick picture of me, and then Brian there below. The things I'm going to talk about today during the presentation are apps that were developed for noting bacterial zones of concerns in the Gulf, and that's the first one that you see here. This was done under an Office of Research and Development, or ORD, grant funding back in the day, and we have not updated it, but we do have new funding to update these starting now. And then the bottom tool there is an app that was developed for teasing out environmental and health data visualization relationships in the United States. So we'll talk about that. I just wanted to say quickly a few words about some of the things that I've done at the agency. So on the left, there's an image that says PM 2.5 in Kampala. So I was a Embassy Science Fellow for the State Department, and I was able to develop this, package it up, get it off to my counterparts over there in Uganda. And I'm originally actually from Uganda, so this that project was near and dear to my heart. But they were able to get $1 million Google grant after all of that good work. And so they now actually have apps that look at PM 2.5 in the capital city of Uganda. So kudos to them. Just a quick fun fact about myself: I do have 5 degrees, and then I went back to school to get a certificate in making maps. And I did all this while working, support of my parents. And so if you're in my situation, I had to actually work in order to have enough money to go to school. Just keep at it. Don't ever give up is my message there. And everything you'll be seeing here, do know that we worked with a lot of folks to put this presentation together. Brian and I, scientists, engineers, but we do have artists, right? Lawyers, folks who are great at communicating at EPA. And so thanks to them for this presentation. And with that, I'm going to turn it over to you, Dr. Chastain.
Thanks, Saw. Yeah, I just wanted to say that we do have a long history of working with data visualization at EPA, and it comes in many forms. Some you might expect, so doing things like tracking water and air quality and soil quality, things like that. And other ones maybe you might not expect if you're not familiar with our mission, things like tracking health outcomes with partners like the NIH. Also, what was mentioning partners and our co-presenters here, we also work with NASA for things like tracking climate change and how that affects the environment as well. I also wanted to talk about one specific project that was mentioned earlier by Administrator McAllister, was the AirNow website. This is a good example of the data visualization that's done at EPA, because it was originally a website that was devoted for publishing air quality results around the country. But when it was originally published, it was in the early 2000s, and everything was very static and a lot of text and not easy to navigate. And it wasn't really, that didn't get wide use by the broad public. A few years ago, maybe 5 or 6 years ago, we revamped it and used more modern data visualization techniques, interactive, worked with feedback with our audience to make sure we're providing exactly what they're interested in. And as a result, it's been extremely successful. Like I mentioned earlier, like the most visited website during fire season. President Biden showed it off during the last fire season last year. I think the map on the screen here is from that fire season from June of that year. And it gets even surpassed like the USPS tracking that day. So it's been very successful. But I bring this up not as to brag on the work we've done, but to really emphasize the need to have that evidence-based use of data visualization. Something I talk with my students about, like not just to take your data in tabular form and throw it out and make a pretty map or pretty graph, but think about how the users are going to interact with it. What is the question they're trying to answer? And then go back and forth and look and see, is this getting what we're trying to get? And look and see, you can perform those type of analytics to see, yes, this is, they're able to get what they're trying to do. And we're seeing this spike, and they're, obviously it's providing a service that's been needed out there. So the evidence-based usage is really important thing to talk about. Next slide.
Thank you so much, Dr. Chastain. And it has been an extreme pleasure of mine to get to work with you over the years on the tools RED that we're going to be talking about here shortly. So disclaimers are really important at EPA. This is another one, just so folks understand. So some of the tools that we have developed are excellent. They help us note hotspots, but they do need to be ground truth. And so that's one of the reasons why we're doing this presentation, to get this information out to the general public so that you can provide us feedback on some of the things that we've done over the years. Also, collaborating with others is extremely important. So Dr. Chastain and I have worked with folks from New Zealand to CDC. We've taken a very multidisciplinary approach at putting these things together, which will only enhance these tools. So feedback, the two tools that I'm going to focus on are RED, R-E-H-D, as you can see there, and SAMI, S-A-M-I. Please feel free to contact us at rehd@epa.gov, so red@epa.gov, to get us your thoughts, feedback, whatever you have on the tools that you're about to see, because we do want to hear from you. We want to develop tools that will be useful to the public, right? So the one on the left here that I'm hovered over is the RED Viz app. It has environmental health data visualization. Dr. Chastain developed it. He has done an amazing job. And from here on, we have a new group. We have new funding to update this tool. So we're looking forward to getting your feedback. Keep in mind the functionality of the tool. A lot of this is out of the box, so he's done a great job there. So some of the comments we would love to hear from folks. Things like, what other data layers would you like to see in this? We're thinking about adding what's called health impact assessments, HIAs. So we're really excited about that. We have several subject matter experts to guide us on that conversation. The tool on the right, it's called SAMI. It was developed to note bacterial zones of concerns during flooding, hurricane storms. And so you'll see a little bit about that here. Again, some of the layers that are in it, we're going to be pulling into RED so that we can run some statistics on this and see how that data fall. So thanks again to NASA for presenting with us. This is off of their webpage. Brian and I were interested in that carbon dioxide information. They do have a time series that's very, very interesting. I'm going to play a little bit of it. It's the month of November from 2002 to 2022. Note those areas that are yellow to red are high in concentration of carbon dioxide, and then note that those areas that are blue to green as it goes through the years in the month of November. Notice we never actually go back to light, we just continue getting darker. So that one was about air quality. And so this next tool, it's called the Regional Environmental Health Data Viz app. I'm just going to go ahead and play this short video about this one. Thank you so much for watching this instructional video on the Regional Environmental Health Data Visualization app, or the RedViz app. Here's the link to the app, and below that is a QR code. Once you click on the app link, a disclaimer pops up from the CDC National Environmental Public Health Tracking Network. You've also provided a note. Basically, these are visual relationships, and the tip, select variable X, then Y. Click OK, and you'll notice the title at the top left. Click here to get to our EPA home pages. Click here to export the data. We have a data source section. Click on any of these links to learn more, or just contact me by clicking here. I'm Sala Senkai. There are 3 things that you can do within this app. First, you can filter by state. Remember, this is optional. You must, however, select a variable X and then a variable Y. To note the variables within the tool, simply click that drop down, scroll through the available variables. They're the same for both X and Y. I'm going to select low birth weight, the annual average, number of very low birth weight, those less than 1,500 grams. We're going to look at that alongside variable Y's, PM 2.5 annual average monitored and modeled information. Remember that everything to the left relates to variable X, and everything to the right relates to variable Y. We're going to start with the middle section here. First, I'm going to focus on the years. So the years go from 2022 all the way down to 1980. You can loop through the available years by clicking here, and I'll do that later. You can also sort through the data table. Click on location and it'll update this alphabetically. Click on variable X. You can sort from smallest to largest or largest to smallest, which is what we have here. To note variable X within the scatter plot, note the bottom axis here. So as I go from left, 0, you're going from smallest to largest. As you go from left to right, this area is the largest for this variable. And you can see that here and also in the data table. I can also sort variable Y, and from bottom to top, you're going from smallest to largest. And so the area that's largest here, I'm hovered over that. I'm going to sort variable X again. Note that anything in the top right is going to be high for both of these variables. We're going to focus on variable X. We're looking at the year 2012. Notice we have information from 2004 all the way down to 2015, and we don't have any information outside of that. I'm going to hover over 2012 so we can see the annual average value is 21.06, and you can also see that here. And I would do the same thing for variable Y, but you can do that on your own. Next, we'd like to zoom in to region 7, so I'm going to click here and select Iowa by typing in I. You'll notice all the areas that actually have an I with them. The bottom two here are dark gray, meaning we don't have any available data for those two, but we do for Iowa because it's white. So as I click on it, it turns green and there's a check, meaning I've selected it and there's information and data for it. As I hover outside of the state, you'll notice nothing happens, nothing pops up. So for those areas that are white and outside of the state. For those areas that are white and within the state, you'll see a null value. The dark blue are high values for what I've selected, and then the yellow are low values for what I've selected. And that's for both of these variables. Next, I would like to focus on the scatter plot and circle or select those areas that are high to the right for variable X. I do that, I have to close this. Once I do that, the app will zoom in to those areas. And I can also help it here by scrolling with my mouse. So I'm closer now, and you can almost see the water bodies, but you can see the way the variables lay. So as I zoom in, I'm going to change the base map by selecting street. You can see that there. A world imagery that you can see here. We'll go back to that default. And again, you can see those water bodies. To X out of this, I'm going to click this red circle here. And we go back to that state. I'm going to select the other states within this region. So we have Nebraska, Missouri, and then Kansas. And as I select them, they turn green and there's a check. So this is one way to actually pull those areas closer to the map by selecting on and off on the states if it doesn't zoom automatically. I can also hover within, again, the scatter plot to note those high and low for both of those different variables. I now would like to either deselect these 4 states by clicking here, or I can go back and just select each one of these green options with a check and they go away. And now we go back to the default of the entire US. Next, I'd like to just quickly download or export the 2 variables that we're looking at by clicking there. It'll export it into an Excel format like this one, and you can see the information is the same. So now someone can use that in their own tools or analyze it the way they would like to analyze it outside of this app. The last thing I'm going to do is loop through the years by selecting or clicking on this. And as it goes through, you'll notice it starts where the available years 2002, 1 and 2 for variable Y, and it'll go all the way to the end, 2015 to the latest date. Once it gets to 2004, you'll see the scatter plot populate, and then it'll continue on. Please feel free to contact us if you have any comments or questions. And again, thank you for watching this instructional video. So that is the tool that Dr. Brian Chastain has developed. He developed it in Click. And again, please give us your comments, your feedback, what other layers you think would be needed. And there was a QR code, so you can go back and watch the video if you want to get back to the Viz app that we just demoed. So the neat thing about it is you can review it in English. I'm hovered over the data source here. There's also Spanish, Vietnamese. There are just under 100 different languages, including the one that my family speaks. There are a lot of benefits to apps. We've talked about it throughout this presentation. First, identify data gaps. You saw that really quickly. Agency-wide consistency helps us prioritize areas of interest, whether those are counties within a region, state, or even agency-wide. Also, both with bolstering tribal and EJ community resilience, basically assists with noting those communities that are marginalized, underserved, and overburdened, irrespective of location, whether you're in a rural area or a densely populated one. You just saw that video. We do have 3 of these apps. And thanks to Cherokee Nation for working with us there in Oklahoma on pulling in some of their interesting data. Next, we're going to talk about Source Assessment Mapping Interface, or SAMI, just really quickly. Again, let us know what you think about this one. It's really important to actually depict bacterial zones of concern during these kind of storms, so we can get that information to first responders. This is an image from NASA about Hurricane Harvey that made landfall on August 25th, 2017 and flooded the Houston area. I zoomed in there. Beautiful imagery. Even the video is just amazing. Again, NASA, our eyes in the sky. They've done a wonderful job here. Keep in mind that this hurricane has been documented on record to be the 2nd most costliest one in the US after Katrina. And again, this shows you flooding. This image, thanks to NASA, FEMA. And speaking of some of the satellites that we talked about, that was talked about earlier on in this this segment, the NASA segment, this one depicts how Harvey saturated areas in Texas. So the image to the left is just before, and then the one to the right is just after. What you want to note is this color here, this light yellow, not as saturated as the dark blue, almost gray. And you see the just before, saturation was mostly to east of Houston, and then after Harvey, you do notice that Houston was saturated. Another image from NASA. This shows us the coast, the muddy sediment-laden waters coming from Houston and going into the Gulf of Mexico. So thanks again to NASA for that image. That brings up the importance of SAMI in developing this tool. This video is going to play. SAMI was developed by Dr. Rajvir Parmar, Dr. Sai Tursky at ORD, Office of Research and Development, and John Eastman. So John Eastman is actually driving this video here, but what you see is he's adding points where you would expect to see bacteria, and then he's hovering over those areas, and so that hazard danger level to the top right shows you just, this is an example, but it shows you the expected concentration of bacteria in those areas. So what he does is he right clicks, then he adds the intensity, so how dark red is it, and then the dispersion, the distance away, and then he gives it a name, he clicks submit, and then it adds it to the tool. So this is manual, but one of the things we want to do is update this so it's automated. And that way first responders would have that information as they go out into the field to do the good work that they're doing. So you can look at these 2 points relative to each other or just absolute values for each one of them. There's also an exponential and a linear feature that they added to this tool. So as he's clicking on these things, you're noticing the red and the dispersion changes and updates really relatively quickly. So again, there's the linear, and then he's going to show you the exponential dispersion. So again, this is made up information, but it's a useful tool. We were focused on Houston. Now we're going to move over to New Orleans, and he's showing you how to add the shapefile. Again, this is something that we would like to automate within the new version that we start to work on with the new funding that we've been provided. So as you zoom in, you can note those dark areas of concern, right, where we would see bacteria during some of these storms. So a very useful tool. We're going to pull those layers into red and then run some statistical analysis on it, and then pull it back into SAMI. But get us your feedback at red@epa.gov. Are you, let us know things like what data layers should we pull in here? Would you like to see these on your phone or on a computer? These are some of the things that we would be interested in knowing. And then what kind of projects would you think would be useful for these kind of tools? So that ends my presentation. Just a huge thank you to everyone involved in putting this on today. If you want to know more about some of these tools, here's our EPA Region 7 Science Program QR code. Just go there in the future to learn more about it. And just, again, a heartfelt thank you to all the participants, all the presenters, and an early Earth Day to everybody. Next, we are going to do a quick discussion Q&A. So I'd like for the following folks to go ahead and turn on their cameras and say hello to everyone. And I'll invite our NASA folks as well. So we have Dr. Carol Ann Gross Davis. She serves as a senior scientist and epidemiologist in Region 3. We also have Ellie Hagan. She's with Region 5, and she's an environmental justice scientist there. We have Dr. Alicia Dutton. She's a toxicologist, risk assessor for Region 7. Dr. Eleodora Chamberlain is our Region 7 Regional Science Liaison. And then we also have Chelsea Berg, who's with our EPA Office of Research and Development, and she's helping with stakeholder engagement and user testing and feedback. So I haven't been watching the chat, but if folks want to come off camera and ask a question, I know that they can raise their hand to do so. Since I'm in share mode, I actually can't see the questions. So if anyone would like to start with some of the questions that we've gotten. NASA, did you see any questions for you? All right.
Yeah, I saw one question from Palumi Abiodun. I apologize if I mispronounced your name. With regards to the NASA data, is there a specialized training for students towards handling and analysis of such? I've put a link in the chat that one of our support will post into the everyone chat. Sorry, I'm not a Zoom user regularly, but we do on our Earth Data website. There's a number of learning resources that you can access for all levels. And that's where I would recommend starting. And if you have further questions or further needs, get in touch with the teams there, and they can point you in the next direction.
Thank you, Ellen.
Mm.
Anyone else?
Sala, this is Carol Ann. There was a question for you about what was the certificate that you pursued for you to get certified in MAPS GIS?
Okay, yes. So at the University of Texas in Arlington, so I went to several universities in Texas. There's an earth science and environmental science certificate that somebody could get, and it helps you with a lot of different spatial analysis. And yes, it was really relevant at the time. And so I thought, why not go for it? And I'm glad I did.
So just a general one that says, asks, where will this recording be posted?
Yes. So please go back to our, let's see, region 7 right here. So you can scan that QR code. We are working with Dr. Elidora Chamberlain. She is our region 7 RSL. And so she will probably, I don't know how soon we can get that up, but she'll probably be working with everyone on getting a YouTube link to that video, and then we will provide that to the masses. So thank you for that question. We have a couple minutes left. I would like to do something really fun before we go. I would like to get 3 snapshots. We do have Kevin on the line, so he will be taking screenshots. And so what I'm going to do now is attempt to stop sharing. And that way we can all see each other. And if folks would like to come on, and so please, we want to see real people, not pictures. We're going to take a series of photos here really quickly. And so Kevin, are you able to, Mike, I think what's happening is are folks able to
We
turn
would
on?
have to promote them to panelists.
Yeah, that's what I was thinking.
Yeah, and unfortunately, we have to do it one by one. We can start working through it if you want to. There's 34 people here.
Who have raised their hand to turn it on? Okay, that's fine.
Oh, no, actually, yeah, we can promote it. Just go ahead and raise your hand and we'll go ahead and promote you to panelists and get you enabled.
All right. So do we want to, are you working on that?
Yes, yeah, and I probably got Zoom support helping me out as well.
Okay.
Yep. If you've raised your hand, you should get a pop-up. Just accept the panelists and
All right.
you'll be added.
And thanks, everybody.
In the meantime, there's a question about what kind of degrees or information would you recommend for people to learn? And that may be largely, folks from NASA could answer that.
Yeah, I'll start. I have a degree in science and I have a degree in journalism. I work in as a public engagement person. My passion was always writing, even when I was interested in science. And I think that's really the answer, is you got to follow what you're really interested in. There are career opportunities across NASA, across EPA, across federal agencies, across science domains that need skills of all sorts. And when you're thinking about data visualization and communication and sharing science, you don't have to be a scientist, though science is incredibly exciting and fun to do as well. So I just want to put out there, there's lots of options, but really it's what are you passionate about? What are the courses that interest you the most? What are the ones that you want to go back to and continue to go to every single day? Because that's kind of what a job is. You're going, and I feel like I'm learning every day, but I'm also learning in the field that I love. So follow your passion is the advice. I know it's lame, well, not lame, but like cliche. That's what I'm looking for. It's cliche. But it's true. There are lots of opportunities as long as you are passionate about what you do.
Perfect, Ellen. I think you said it. Yes, I see people clapping, so that's wonderful. All right. So are you able to get a quick screenshot there, Kevin? Let's do a count of 3. 1, 2, 3.
Perfect. Got it.
Awesome. Thank you for that. Thanks, everyone, and have a great rest of your day. Happy Earth Day early and solar eclipse. Go out there and have some fun.
Can I ask a quick question?
Yes.
Are you guys available to, with my program here in Iowa, once our grant gets up and running, we will have youth environmental justice navigators. Are any of you guys that were on the panel today, in particular you, Sala, would you all be available to do some training and education for our folks, either in person or online?
I would be willing to talk to anyone about the tools that we're developing here. Yes, yes, yes. Please contact us at the red email box, yep, at epa.gov, and we will definitely, we'll be there for you, yes.
This would be good, because I think having the youth be able to see it, play with it, the different instruments, things like that, you want feedback. I want to get the youth involved as much as possible, and I think they'll probably do an even better job than somebody as myself, because they're way more into technology than I am. So that would be great, so thank you.
Thank you, Kimberly, and thanks for all that you do for the community. Yeah, educating the youth, that's important for sure. Yep. All right. So, Mike, I guess we are done with our EPA Converses with Students for 2024. All right.
Great. Thanks,
Thanks,
everyone.
everyone. Have a great day.